Notice this one does not have an exponent. I can't rewrite it as a common base. However, I can use the log base button on this. Log base 4 of 21 is going to equal 1 minus x. So I'm going to type this in and get a weird decimal and then start solving it for x. So I'm going to hit the log base button. I'm going to type in the 4, right arrow, 21, hit equals. So it equals 2.196. Now I'm going to subtract 1 from both sides. So I'm going to subtract 1 from this. That's 1.196. 1.196 equals negative x. So that means my answer, x, is going to equal negative 1.196. Choice C. They want me to solve this. You could plug in the 5 or root 5 or negative 5 into each of these. I instantly know it can't be negative 5 because negative 5 minus 2 is negative 7, and you're not allowed to take a log of a negative number. It'll give me an error go to. So I can get rid of that negative solution right off the start. Negative root 5 minus 2 is going to be a negative number also, so it can't be this one. So it's either going to be A or B. I'm actually going to do the actual arithmetic for this. I'm going to change this to a single logarithm. That's going to give me log base 9 of x minus 2 times x minus 2, because the addition gets changed to multiplication, equals 1. The log leg kicks the 9 way over there and then runs away. So that's going to give me x squared minus 4x plus 4 equals 9 to the first, or 9. I'm going to subtract 9 from both sides. X squared minus 4x minus 5 equals 0. Now I can mode 5-3 it. I'm going to enter 1 equals, negative 4 equals, negative 5 equals. 5 is an answer, negative 1 is an answer. Notice my answer has to be 5. I'm going to do the same move for this one. First off, it can't be negative 7. It can't be negative 7 because negative 7 minus 4 is negative 11. You can't take log base 9 of negative 11. So it can't be choice B. A negative minus a negative is a negative. It can't be choice A. So it's either going to be C or D. I'm going to multiply these two together. So that's going to give me log base 9 of x squared minus 8x plus 16 equals 1. The 9 gets kicked over to the other side and pushes up to 1. So it's going to give me x squared minus 8x plus 16 equals 9. Subtract 9 from both sides. X squared minus 8x. 16 minus 9, I believe, is 7. Load 5-3. 1 equals, negative 8 equals, 7 equals. 7 is an answer, 1 is an answer. It has to be choice D, 7. Again, you could have gone through your choices and plugged them in to see if they work. Notice how they're all a log. That means I don't have to do any fancy kick trick, but I do have to combine these. So that's going to be 5 plus x divided by x minus 2 equals 4. You can drop the logs after you combine them. I'm going to multiply both sides by x minus 2. When I do that, these x minus 2 simplify. So that's going to give me 5 plus x equals 4x minus 8. Subtract x from both sides. 5 equals 3x minus 8. Add 8 to both sides. 5 plus 8 is 13 equals 3x. So the answer is going to be 13 over 3. This one has a 1 there, so I just can't drop all the logs. I actually have to do some laws of exponents and rules of logs. So I'm going to subtract log 4x minus 3 from both sides. So that's going to give me log of x plus 10 minus log of 4x minus 3 equals 1. I'm going to combine these because the minus is going to turn into a subtraction. So that's going to give me log of x plus 10 over 4x minus 3 equals 1. Now recall, if there's nothing there, it's a hidden base 10. So my log leg can kick that 10 all the way over, and that's going to raise up that 1. So my final equation that I need to solve is x plus 10 over 4x minus 1 equals 10 to the first, or just 10. Solving this, I'm going to multiply both sides by 4x minus 1. These are going to simplify out. That's going to give me x plus 10 is equal to 40x minus 10. Subtract x from both sides. 10 equals I have an error here. I wrote down 4x minus 1. It should be 4x minus 3. So that should be a 30 there. 40x minus 30. Ten equals 39x minus 30. Add 30 to both sides. That's going to give me 40 equals 39x. Divide both sides by 39. My answer is 40 over 39. I'm going to combine them. X plus 9 times x minus 9. That's going to give me log base 3 of x squared minus 81 equals 3. The log leg kicks the 3 over, so 3 cubed is going to be 27. So x squared minus 81 equals 27, or 3 to the third. I subtract 27 from both sides. X squared, mode 1, negative 81 minus 27, negative 108 minus 108 equals 0. I'm going to mode 5-3 that. Mode 5-3. I'm going to type in 1 equals, 0 equals, negative 108 equals, hit equals again. And that gives me 6 root 3 or negative 6 root 3. It can only be the positive one. Financial problems. How long does it take 5,600 compounded annually to become 11,008? These are nice because you can work backwards and plug them in. So it's a print problem. 5,600. The rate is 0.05. Compounded annually, so n equals 1. And we don't know what t is. T can either equal 13, 14, 15, or 16. And we're going to try them all and see which one gets closest to 11,087. So I'm going to do my formula. 1 plus the fraction bar to an exponent. It's going to be 0.05 over 1 raised to the 1 times 13. So I'm going to start off with 13. And notice I'm trying to get it to equal as close as I can to 1187. So mode 1. And I'm going to type in 5,600, open parentheses, 1 plus the fraction bar, 0.05 over 1, parentheses, to the 13. And we'll see if that equals something close to 11,087. No. So I'm going to back arrow and change that 13 to a 14. Because that's some of my choices. Whew, right on the money. Right on the money. 11087.62. So it has to be 14. What is the rate of the investment? That doubles. Compounded quarterly. If it were compounded continuously, it would be easy. Because it's compounded quarterly, it's going to be tough. So I'm looking to double that. I'm looking to double 6569. So 6569 times 2 is 13138. So I want to find out what doubles it. 13138. So my initial amount is print 6569. I don't know what the rate is. It can be 4.4, 6.6, 8.8, or 10.9. The number of compoundings is quarterly, so that is 4. And the amount of years is 8 years. So I'm going to come up here and I'm going to set it up. 1 plus fraction bar. One of those, 4.4, I'm going to try first, and then I'm going to change it. Over 4 to the 4 times 8, which is going to be 32. So the only number that I'm going to keep backtracking and changing is this rate until it equals double that. Until it equals 1,138. So let's give it a shot. 6569, parentheses, 1 plus the fraction bar. We're going to start off with 4.4%, or it's supposed to be 0.044. I messed up, 0.044. You have to move that decimal over 2 places. Over 4 to the 32nd, and we're hoping it equals 13,138. It does not. So I'm going to back arrow and change it to 0.066 and see if that equals it. Delete, 66. I'm trying choice A now. 0.066. 1190. A little bit higher. I need it to be a little bit more. So now I'm going to type in 0.088. And there it is. 13138, 131. Ooh. That one's pretty close. It's off by $50 though. It has to be that one. It has to be choice C. It was a little over, but it was close enough. How long? An interest rate compounded continuously. Continuously is not print, it's per. So that's going to be an A per. The amount it grows to is 24200. The amount you put in is 8,300. E is my growth rate. 0.057. T for how many years? That's what they want to find out, how long. So it's going to be A per. It looks like this is the formula. So the amount is 24,200 equals 8,300 e to the 0.057 t. I'm going to go through this one step by step. I'm going to divide both sides by 8,300. So that's going to give me 242 over 83 equals e to the 0.057 t. To get rid of the e, I ln both sides. When I ln both sides, the e cancels out, and then I just have to divide by 0.057. And that will tell me what t is. When you type this in the calculator, you have to wrap that in parentheses. ln of 242 over 83, right arrow, close the parentheses, over 0.057, 18.77, and there it is, 18.77 years.
This is actually a nice problem. They give you the formula, and then they tell you to plug in 10. So it's basically just a calculator key in. So 200, shift ln will generate the e. If you hit shift ln, e to the negative 0.025 times the number 10 for 10 years. And 155.7 to the nearest whole gram is 156 grams. If 18 grams of a radioactive substance are there initially, and in 3 years, half remains, so the half-life is every 3 years. So if another 3 years passes, that would be the 6th year, how much would be left? Well, half of 9, and half of 9 is 4.5.